All right, today's lesson, we're still in the Algebra Skills unit. We're doing rational expressions, and this is the second day. Yesterday, we learned about how to simplify rational expressions and reduce common factors. We also learned about this domain exclusion issue, and so we want to make sure that we keep that in mind as we move forward. We also reviewed how to multiply and divide with rational expressions, and today we're going to look at adding and subtracting. When we add and subtract rational expressions, you have to find a common denominator. And actually, what we always want to figure out is we want to figure out the least common denominator. Not any denominator, but the least common one. One issue that I tend to see with these is that students feel like we're solving and the denominator somehow disappears, and that's not correct. When you add and subtract, the denominator does not disappear. All right, so be mindful of this because this tends to be like a common misconception, and we're getting it confused with solving like a proportion. All right, looking at number one, we've got 2x over x minus 5 minus the quantity 5 over 5 minus x. Notice that my second denominator is really close to the first one, but it's just opposite in sign. And notice that this would be equivalent to negative and then x minus 5, right? That would have the same value as the original. Then what I'm going to do is I'm going to multiply, because we know a negative times a negative is going to turn into a positive. And so then I'm going to have 2x over x minus 5 plus 5 over x minus 5. And these have a common denominator now because I dealt with that negative. And so now I can add and subtract the terms in the numerator. And so this turns into 2x plus 5 over x minus 5. And that would be the final answer here. Notice that the domain, we didn't cancel any terms out. We can see with our eyes that the denominator here can't be 5, and so we don't need to say that again. All right, looking at number 2. So number 2, we've got two fractions. Again, the denominators are quadratics. I want to go ahead and factor on both of those and see what I end up with. So for my first denominator, notice that I would have x plus 2 and x minus 1. And then for my second denominator, I would have x minus 3 and x plus 2. Well, now what I need to realize is what is the least common denominator, and I would recommend that you always write this off to the side. So the least common denominator here is going to be each unique factor. So we have x plus 2, and then I've got an x minus 1, and then in my second fraction, I already accounted for the x plus 2, but then I need that x minus 3. So my least common denominator for number 2 is x plus 2, x minus 1, and x minus 3. All right, so now I'm going to rewrite each fraction. So my first one was x, and I'm going to use the denominator x plus 2, x minus 1. So I'm going to use the factored form. And then same thing for the second one. Now, my first fraction is missing the x minus 3 factor. So what I'm going to do then is I'm going to introduce x minus 3 over x minus 3, because any expression divided by itself is automatically 1. Well, then on my second fraction, I'm missing x minus 1. So on that fraction, I'm going to introduce x minus 1 over itself. So then I end up with my denominator of x plus 2, x minus 1, x minus 3. And then my numerator, notice that my first fraction is x minus 3 times x. So then that becomes x squared minus 3x. And then my second fraction is a negative, so don't lose that, negative 2 times the x minus 1. And so that's going to give me negative 2x plus 2. Okay, then when I combine my like terms in my numerator, I get x squared minus 5x plus 2. And then my denominator, x plus 2, x minus 1, x minus 3. And again, I didn't cancel out any terms, so I don't need to worry about the domain. It's obvious that the exclusions are the zeros of the denominator. You do want to use your eyes and just double check that this can't be factored, because if it could be factored, then you would want to reduce. All right. Looking at number 3. So on number 3, I've got 2 over x plus 1, and then I've got 2 over x minus 1, and then plus 1 over x squared minus 1. Well, when you look at that, notice that the last denominator is one of our patterns, and x squared minus 1 is the same thing as x minus 1, x plus 1. And so in this case, that is going to be the least common denominator. So again, you can write it in its factored form, or you can think about it as x squared minus 1. It doesn't matter. So my first fraction is missing the x minus 1. So I'm going to have to introduce that onto the first fraction. And then my second fraction is missing the x plus 1. And then my last fraction isn't missing anything. So once I do my combining, my new denominator is going to be x squared minus 1. And then notice when I multiply x minus 1 by 2, that's going to give me 2x minus 2. And then my second fraction, when I multiply 2 with the x plus 1, I'm going to get 2x plus 2. And then my last fraction just has a numerator of 1, so we don't want to lose that. We want to make sure and have that on there. Notice that the 2's cancel, and my numerator is 4x plus 1. And then the denominator is x squared minus 1. And again, you don't need to say that there's any exclusions here, because it's obvious that the x values could not be negative and positive 1. Those are not in the domain. All right, the next type of rational expressions that we're going to look at are compound fractions. And compound fractions are just fractions within fractions. To simplify these, in my opinion, the best way to handle this is to multiply the top and the bottom by the least common denominator to eliminate that. All right, so let's look at number 1. So when I look at number 1, I can already see that my domain exclusion is going to be off of that term there. And so I know that the x value cannot equal negative 1. Now, what is the least common denominator of all of the denominators in the numerator position and the denominator position? Well, in the denominator position, notice that you have 1. Well, 1 is really over itself. That's the same thing. And so then we just have the one denominator of x plus 1. And we happen to have the same thing in the numerator as well. So for this one, the least common denominator is x plus 1. So what we're going to do then is we're going to multiply the entire numerator and the entire denominator by that. Now, when we're doing this, you have to use a distributive property step because the numerator is a sum and the denominator is a difference. So what I have to do then is I have to multiply the x plus 1 times each term of the numerator, and same thing in the denominator, each term of the denominator. So in my numerator position, 1 times x plus 1 is itself. And then on my second term, the x plus 1's cancel, and so I'm just left with x. In the denominator position, 1 times x plus 1, again, is itself. And then, again, the x plus 1's cancel, and then I'm just left with the x. And again, don't lose that minus. Doing a little simplifying here, notice that I get 2x plus 1 because the x's in the denominator here cancel, and we never write an expression over 1. So my final answer for this is 2x plus 1, but I have to deal with the fact that I canceled out that common denominator. So this is only possible if the x value is not equal to -1, and there's no way that you would be able to tell that when you look at the final answer there. So you have to make sure that you state the exclusions if there are any, if it's not obvious in the answer. All right, let's look at number 2. So on number 2 here, notice for the domain in the denominator here, we can clearly see that y cannot equal 0. All right, so we'll deal with that when we're done. Now here, notice that the least common denominator, so we're going to need this y factor, one of them, and then a 2y plus 1. So the least common denominator for this is going to be y, 2y plus 1. So the entire numerator gets multiplied by y, 2y plus 1, and then the entire denominator gets multiplied by the same thing. Now again, you have to be really careful. You have a distributive property step. So this entire expression has to get multiplied by each term in the numerator. And so you've got 5 over y, and then you have 6 over 2y plus 1. And similarly, the denominator, you've got 2 terms again. So you have to do a distributive property step there. Well, my numerator, so I'm going to work this first term here. So 5 over y times y, 2y plus 1, is going to be 5 times 2y plus 1, because the y's are going to cancel out. On my second term of the numerator, so that's this term right here, the 2y plus 1s are going to divide out. So then I'm going to be left with minus 6y. Okay, for my denominator, so working my first term here, so 5 over y, the y's are going to cancel, so I'm going to be left with 5 times 2y plus 1. And then on my second term, nothing is going to cancel, so I'm going to be left with 4y plus 4y times 2y plus 1. All right, now it's just a matter of simplifying and combining like terms. So notice on my numerator, I'm going to end up with 10y plus 5 minus 6y. And then my denominator, I'm going to have 10y plus 5 plus 8y squared plus 4y. Right, and so that's going to give me 4y plus 5 in my numerator. And then my denominator is going to be 8y squared plus 14y plus 5. Now, I told you, I think it was yesterday on one of the problems, you have to double check that you can't reduce on any of these fractions, because if you can reduce on the fractions, you need to do that. So common factors always need to be divided out. So what you need to do then is you need to check the denominator here and make sure that you can't factor this. All right, so my numerator is still 4y plus 5. Well, 8y squared could be 8 and 1 or 4 and 2, and I'm envisioning that it's going to be 4 and 2. So if I do 4y and 2y to get that middle term to be 14, notice that I would need, let's see, if I do plus 1 here and plus 5 here, I would get 14y, and so that middle term does check. And again, when you're checking for your factoring, you're using the visual cue of the numerator, because if it's going to reduce, that's going to be the factor that we're going to, divide out if it's a single factor. So that's why I jumped right into using 4y and 2y, because I'm expecting that if I can factor it, it's going to cancel with that in the numerator. So then the 4y plus 5's divide out, and now I'm left with, finally, 1 over 2y plus 1. Okay. Well, now we've got to talk about the exclusions. So remember, on the original problem, I had that y value couldn't be 0, so I need to make sure and say that. And then, of course, my factor that divided out the 0 for that one is negative 5/4. So that's another exception. So my y value could also not be negative 5/4. That would be the final answer then for this problem. All right, go ahead and flip your paper over. We've got a couple more. All right, in number 3, I've got 1 over x minus 1 over y, all divided by 1 over x plus 1 over y. Now this one, the domain for the original is a little bit trickier, and I think that you can automatically see immediately that the x value and the y value could not equal 0. But actually, it's going to be a little bit more complicated than just that. So we know that this problem doesn't exist if the entire denominator equals 0. So look at what happens. So if I do 1 over x plus 1 over y, and I set that equal to 0, notice that I could get 1 over y is equal to negative 1 over x. And then I could say that y is equal to negative x, or you could have negative y is equal to x, it doesn't matter. So this is going to be all of the problematic x values. So you actually have more than just 0 being a problem. Anytime that you choose the same value for x and y, if one is opposite the other, then that's going to be a problematic value. So for this one, these are going to be the exclusions then for the problem. We cannot have a y value equal to negative x, or vice versa. You could say x can't equal negative y. So let's see what happens with our final answer for that one and see if we need to include that or not. All right, going back to the original problem, so my least common denominator here, this one's kind of easy, is xy. So my entire numerator multiplied by xy. And then same thing on my denominator. And again, be mindful that you're doing a distributive property each time. So I'm taking xy times both terms of the numerator and both terms of the denominator. So my new numerator is going to be y minus x, and then my new denominator is going to be y plus x. Now, do you need to state the fact that y cannot equal negative x? And the answer is no. It's obvious in the answer here. right? Because again, if you set that denominator equal to 0, you get what we already figured out here. And so that is already obvious in the answer there. All right, last one, number 4. So notice on number 4, you're going to have a problem if the x value is equal to -1. So we want to make sure that we note that if needed. The least common denominator here, so I need an x and an x plus 1. So my entire numerator and denominator needs to get multiplied by that. Again, it's a distributive property step for each in the numerator. And then the denominator, it's just the one term. So I just multiply that together. So my first fraction in the numerator turns into simply x plus 1. And then my second fraction, the x plus 1's divide out. So then I'm left with minus x. In the denominator, the x plus 1's cancel. And I'm just left with x. And then notice here that I get 1 over x for my final answer when I reduce. And again, you could never tell that there's an exclusion besides 0, so we need to make sure and state that. So it's all the reals except x cannot equal -1. And again, we also know that x can't be 0, but that's obvious in the answer, so that's why we don't say it. All right, that concludes the lesson for rational expressions, day 2. Good luck on your homework assignment.